Hello everyone, myself Ankit, and today we are going to study about hybridization in organic compound, basically in alkane, in alkene and in alkyne. So let's start the class. Hybridization in alkane, alkene and alkyne. So before starting the lecture, I assume that you know what are the basic three hybridization that we follow in alkane, alkene, alkyne. In alkane, there are single bonds with carbon atom and 4 hydrogens are attached with this carbon. So if I ask you that what is the hybridization of this carbon, you would say me that this carbon is sp3 hybridized. Same way, if we move on to alkene, this is carbon-carbon double bond, and if I ask what is the hybridization of this carbon, then you would say me that this would be hybridized as sp2, and in alkene hybridization is sp2, and in alkyne, if I ask you that what is the hybridization of this carbon, this is sp hybridized. Okay, so today we will discuss how this sp3 comes, how this s orbital and p orbital intermix, and how this sp3 hybridization is going to make. So if I ask you what is the electronic configuration of carbon, so it is very simple. Carbon has got 6 electrons in the outermost shell, 1s2, 2s2 and 2p2. Okay, so this is the s orbital which has got 2 electrons. This is the 2s, it will also be getting 2 electrons, and this is the p orbital which will be getting only 2 electrons. Okay, so if there are 2 unpaired electrons, so how this carbon atom is making 4 bonds? So according to Vesper, the number of bonds depends on the unpaired electrons that are present in the outermost orbital. Okay, so it has got only 2, so carbon should make only 2 bonds, but carbon is making 4 bonds. How it is possible? Okay, so let's move on and understand this concept, how carbon is making 4 bond. So let's start with alkane. Okay, alkane, as we know, carbon has got 4 bonds with 4 hydrogen atoms attached. Okay, so here carbon has got 6 electrons. Let's write it: 1s2, 2s2 and 2p2. So when this carbon is making first bond, then this 2p and 2s orbitals are very much means I want to say means the gap is minimum between them. So this electron excites and go to this 2p orbital. So we will be getting 1s, 2s, only one electron, and 2p will be getting 3 electrons. Okay. So this configuration is called ground state electronic configuration, and after the excitement of electrons from 2s to 2p, this state is called excited state electronic configuration. Okay. So now we have got 4 unpaired electrons. Now hydrogen can come and okay, sir. Now hydrogen can come and make 4 bonds. No. Why? Because in this you can see that there is a 2s and 2p orbital. If I make now bond with the hydrogen atom, there should be one bond such that will be lower in energy. But we all know that the 4 bonds in this carbon atom are of equal length and equal energy. But if I do bonding with this 2s and this 2p, then the one bond in hydrogen which is bonded with carbon will be gaining less energy as compared to 2p. So what happens now that this 2s and this 2p orbitals will intermix to form new orbitals. Why? To gain equal energy and equal bond length can be formed. So this 2s and this 2p orbital intermixed to make a new orbital, and these 4 orbitals are now sp3 hybridized. Every orbital is sp3 hybridized. I hope I am clear with you. Now 4 hydrogens can come with their 1s, 1 electron in opposite spin, and then can give their electron to make the bond. I hope there is no any doubt in this concept. Let's move forward. Now, if I say how will be the geometry of this structure that is made by CH4 molecule. So we all know there is a repulsion between lone pair, bond pair and bond pair. So there is a maximum repulsion between the lone pair and lone pair. Then it is a bond pair repulsion. Sorry. Then it is a lone pair bond pair. And at last, bond pair repulsion. So we know that bond pair repulsion is minimum, but there is a repulsion. So this 4 hydrogen will attach itself in carbon in such a way that they would attain the maximum distance that can be attained. So this geometry can be only attained in tetrahedral structure. This geometry can be only attained in a tetrahedral structure. So for example, this is our carbon, and This is the 4 orbitals we have attained after hybridization, which has got 1 electrons each. These 4 hybrid orbitals are sp3. So sir, how these orbitals are formed? How this shape is attained? Let's move on to a small basic concept, that is s orbital is what? Spherical shape, and p orbital is what? Dumbbell shape, we all know. So then these two orbitals combine, they are something like this. This is hybrid orbital. So that only orbital I have made. Now 4 hydrogen atom will come with their 1s electron and do bonding with this carbon. And the bond angle which is made between these two hydrogen bonds are 109 degree and 28 minutes. I hope I am clear with this. Next, we are moving on to sp2 hybridization, which is carbon-carbon double bond. Same way, this carbon has got 6 electrons, which is 1s2, 2s2 and 2p2. This is called ground state electronic configuration, and I am directly writing the excited state electronic configuration 1s2. I hope you are clear with this excited state. 1s2, sorry, 2s1 and 2p3. This is the excited state electronic configuration. Next, in this carbon, if we talk about same way, this will be 1s2, 2s2 and 2p2. This is the ground state electronic configuration, and 1s2, 2s1 and 2p3. This is the excited state electronic configuration. So now let us see that this carbon is doing bonding with this hydrogen and this carbon, and the same way this carbon is doing bonding with carbon and 2 hydrogens. So here the orbital needed are basically 3, 1 for carbon and 2 for this hydrogen. So the hybridization would take place between 3 orbitals, 1 s and 2 of the p, 1s and 2p. So the orbital used are 1s and 2p, so its name will be sp2. Next, here is one orbital which is unhybridized, and it has got 1 electron. Same, if I talk about this carbon is also doing bonding with 1 carbon and 2 hydrogen. So the orbital will be used only 3, 1s and 2p, and 1 ion hybridized p orbital will be present. Okay, sir. Here I write its hybridization, which is sp2. Each and every orbital is sp2 hybridized. I hope I am clear with you. So if this carbon is doing bonding with this carbon, so this electron will be doing bonding with this electron, okay, and the hydrogen, which is 2 here and 2 here, which has got 1 electrons, will be doing bonding with these orbitals, and this 2 hydrogen will be doing bonding with these 2 orbitals. I hope I am clear with this. Next, if I see the structure, so this carbon has 3 hybrid orbitals. This is the first, this is the second, and this is the third. And the same way, the opposite carbon has also got 3 electron hybrid orbitals, which has got 1 electrons, and this carbon atoms both are doing bonding with the same way I have discussed here. This is the bonding between these 2 electrons which I am discussing, and the 4 hydrogens will come, with their 1 electron in the 1s orbital to do the bonding with the carbon. These are the 4 hydrogens. So this is the shape of carbon in sp2 hybridized. One thing is here more, the thing is that we have got one unhybridized p orbital which do not took part in the hybridization, which is perpendicular to the plane. It has got 1 electrons each, and this will do bonding, this will do overlapping to make carbon 4 bond satisfy. This is the sidewise overlapping, so that this carbon atom will do and it will complete its 4 bond. The first bond that is made by the hybridized orbital is called sigma bond, and the sidewise overlapping which is made, this is pi bond. So there are 1, 2, 3, 4, 5 sigma and 1 pi bond. I hope I am clear. Next, last, hybridization in alkyne, which is carbon-carbon triple bond. So if we talk about this carbon, this has got electronic configuration 1s2, 2s2, 2p2. In the ground state electronic configuration, and in excited state 1 electron will jump to 2p, And in the same way, this carbon has got electronic configuration 1s2, 2s2, and 2p2. And in excited state, electronic configuration, this one electron will jump to this orbital. Now, if I say this carbon is making how much bond? This carbon is making one bond with this carbon and the other with one hydrogen. Same way, this carbon is also making one bond with carbon and other with the hydrogen. So the orbital taking part in this hybridization would be 2. And the 2 unhybridized p orbital will be unhybridized. In the same way here, also this carbon is making 2 bonds with one carbon and one hydrogen, and 2 unhybridized p orbital will be there. So this carbon is making one bond with this carbon, so this electron will do pairing with this electron, and this one electron will be doing pair with one hydrogen, and this one electron will be pairing with one hydrogen. Hybridization of this is sp. This is sp. This both orbital are sp hybridized. I hope I am clear. Now let's see the structure. This is the carbon, this is the another carbon. It has got 2 hybrid orbitals which are doing pairing with each other first, and the next is doing with hydrogen. And there are 2 p orbitals this time which are unhybridized. There are 2 p orbital which are unhybridized. Which has got 1 electrons each. Now these are going to do overlap with each other, making pi bonds. So the same plane will do overlapping with the same plane. And the opposite plane will overlap with the opposite plane. And this will be made 2 pi bonds. I hope I am clear with this structure. The structure name is, what is this structure? This is linear, and the bond angle between this is 180. This is straight. Okay. I hope you have understood the 3 types of hybridization, which are sp3, sp2, and sp. Thank you.